Hello all, welcome to today's tutorial. We are going to learn to perform takeoff and landing today. So before going to further, we're going to learn about arming and disarming. So this is something which we do before we perform any operation with the UAV. So arming is the place when you arm the motors, you can see the spin starts in the motors, but it is not enough spin to perform a takeoff or so. It is just an indication that the motors are ready or the copter is ready to perform the operation. Think of it as a lock and unlock system so that you cannot perform any operation without arming the motors, in which way it can give you safety so that you don't want to perform some operation mistakenly or maybe unintended operation. You don't want to do some things. So by arming and disarming the motors, it helps you as a locking and unlocking the vehicle. And also there is an advantage for arming and disarming the motors. The flight controller, every time when you turn on the copter, it's going to perform its calibrations and everything. It's going to check everything is okay. If it notices that any problem is there with any sensor, let's say the IMU is not aligned properly, or maybe your GPS is not aligned properly, automatically the flight controller is not going to arm the motors. In such a way, it is going to stop any catastrophe that can happen because of the failure of certain aspects in the flight controller. So think of it as a safety procedure a pilot does before it's going to take off its Cessna 172 or so. It's going to perform all its safety checks, and then they perform, once the safety checks are done, then they are going to go ahead and perform the takeoff. So it is the same procedure the flight controller is going to do. And if there is any problem with that, it's not going to arm the motors. So those are advantages of arming and disarming. So when you arm the motors, you can see that the motors actually start spinning, but they are not going to generate enough thrust to take off or so. So yeah, as I mentioned before, so when you arm the copter, so you can see that the motors start spinning at this point. So which means it is an indication that it is ready to fly. So for the takeoff and landing, for takeoff, you need to run the motors at a higher speeds, like or the required speed to take off in such a way it's going to generate the required thrust. The takeoff case, after arming the quadcopter, so when you give enough thrust, it is going to create the pressure difference by rotating the motors along the propellers, of course. By creating the pressure difference, it creates the enough thrust to take off from the ground. So as you can see that, if you see that the motors are actually spinning in the opposite direction, you can see that the first motor is rotating in a counterclockwise, and second motor is rotating in a clockwise direction, as you can see here. And the third one is again counterclockwise, and fourth one is clockwise, assuming this is the forward direction of the quadcopter. There is a reason for those motors are running in those opposite directions like that. You can have a quadcopter which the motors run like in the same direction, let's say. You can have its anti-clock, 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 and anti-clock everywhere. But there is an issue with such thing. If you can recall the Newton's third law, it says that for every action, there is going to be an equal and opposite reaction. Since the motors are rotating here in a counterclockwise direction, they are going to have an opposite reaction on the stator. So since these are creating a counterclockwise torque, so that it is going to create a clockwise torque on the stator. So since the stator is associated with the body, so we can see that the body starts spinning in the opposite direction, which means when the motors are rotating in a counterclockwise direction, you can see that the quadcopter is spinning in a clockwise direction along its yaw, which doesn't create a stable flight. So to compensate this effect, so we need to cancel the net torque. So that is the reason why we spin the motors in opposite direction. So when we have this in counterclockwise, we have a clockwise motor to compensate that torque. Similarly, we have counterclockwise and clockwise. When we have hexcopter, we do the same thing. We alternate each motor spinning direction in such a way we can have a no spin while the quadcopter or the hexcopter or the octocopter is flying. Here I could recommend these videos, which is actually from a channel called Lesics. I'm placing the links for this in the video as well, in the description of the video as well. So these are wonderful videos with explaining how actually a quadcopter flies. These are actually wonderful videos to demonstrate this principle with the good graphics. It is very nicely explained, and good thing is that both of these videos are under 10 minutes, so which is nice. So please go ahead and check. It's gonna tell you like why actually these motors need to spin in opposite direction, and also how we are going to use that phenomenon to achieve the yaw motion, or maybe the quadcopter flight, the navigation along the X and Y and Z axes. We're going to talk about that in the next tutorial, but feel free to check meanwhile. Takeoff. In such a way, when we create enough motor spinning, so they're going to generate the thrust, in which case the quadcopter is going to take off. And we decrease the spinning rate to perform the landing operation. So that's all for today. Now we're going to go for the practical, and we are going to actually program our quadcopter to arm and disarm, and as well as take off and landing. So now we're actually going to do some takeoff and landing testings. Before we actually do that, I'm going to do something here. So I'm actually going to put a name to our drone or multirotor. So it's actually achieved by setting the vehicles in the settings file, vehicles, so I'm gonna call it UAV. You can call whichever you want. So for the vehicle, we need to define the vehicle type. Like there are several types like simple flight, PX4, Ardocopter for Ardocopter settle, or maybe CV mode, which they say computer vision mode. We're going to use simple flight for now. Later we are going to use Ardocopter when we actually do the settle. It's called simple flight. So that's it. We're gonna go to our environment and open it in our environment. So okay, we have our drone here, or maybe UAV, whichever you call. So we are going to write a script now to perform a takeoff and landing operation. So we're gonna import the library HSIM. So HCM does it like in a way of client connection, thing like that. So we are going to connect to our vehicle to perform the takeoff and landing operations. So here we're gonna enable the API control actually to control our drone. So this one takes only one argument, like you just can say true if you don't name any name to your UAV. So here, since we name it, so we're gonna say which vehicle we are going to enable the control. So for us, this case it is UAV, so we're gonna say it's UAV. You can not just name it and you just give true, that's going to be fine, but I like to give it a name, so in case in future, let's say if we want to add another drone or another UAV, it's gonna be easy for us, so we don't need to come back and change everything at that point. So here we disarm the quadcopter. Let's say arming the motors. So we'll actually execute the script at this point to check how actually it performs. So one thing is, like here, the quadcopter's motors are actually spinning, if you can see that, but it should not be that way. Like when you have a quadcopter, it is just motors are like just locked. So we will disarm in that case. So we have the same script here. We'll just disarm to show the demonstration also. Okay, obviously you might have did some spelling mistake there, I guess. Actually, multi-rotor client. So okay, you could see that now its spinning got stopped because we disarmed it. And after we disarm, we will sleep for a sec. Input the time. And here our takeoff and landing script goes. Takeoff, landing. And once the landing is performed, we again need to disarm the motors for safety. we'll just print done. So at this point, when we run the script, you could see that the quadcopter start spinning its motors, that is arming, and after that disarming. So let's execute and see. So we have arming and we have disarming. So now we try to perform the takeoff operation. So here we're gonna try this takeoff script. So UAV takeoff. So AFSM has a function to perform the takeoff operation. It's called takeoff async. And we need to give the vehicle name. Our vehicle name is UAV. So this let the UAV take off at this point. But we are not going to execute this one. We are also going to do something. So it's called UAV takeoff dot join off. So what does this do at this point is that it's going to wait until it performs the takeoff operation. So it's not just going to go and execute the below commands once it gives the takeoff command. It's going to wait until our UAV takes off. So the reason for this is that, let's say we have a navigation script after this. We don't want the UAV to execute the navigation script until it reaches the takeoff thing, right? So it's same like sleeping, like giving some time to sleep, like, you know, if you write an Arduino script or maybe a Raspberry Pi script, when you give a command to your robot, you're going to wait until it finishes that command. You're not gonna just flash those commands like that. So that is what we're actually doing here. But this function, the good thing is that it's going to wait until the takeoff is performed. We could do here like, okay, time.sleep of 2 seconds or 3 seconds like that, or maybe 5 seconds. But we don't exactly know, don't know how long does it take to perform the takeoff operation. So that is the reason why we have this. So we give this command, so it's going to wait until it performs the takeoff operation. So once the takeoff is done, so we gotta do the landing. So we'll write the landing script here. And we have a function for that as well. So it's called, as you might have guessed it, land async. And we're gonna give our vehicle name. And again, we are going to wait until it performs its landing. We're not going to disarm the motors while it's doing the landing. That's gonna make a crash, so we're not going to do that. So after that, we are doing the disarming. Yeah, here we are doing disarming, not arming. So, and then we are done. So what the script at this point is going to do is that it's gonna arm the motors and it's gonna perform a takeoff. And we will wait for a moment, maybe at this point. After takeoff is done, let's let it hover for maybe 5 seconds. Let's hold for 5 seconds, and maybe we'll place the script here. We'll hover at that point for 5 seconds. And then we will land. So we're gonna arm our motors and perform the takeoff and hover there for 5 seconds, and we'll land, and of course we disarm the motors. So let's go and execute our script. So let's do our first autonomous takeoff and landing, of course in the simulator. Okay, there you go. We have performed our motors, arming the motors, and autonomous takeoff, and hovering for there for 5 seconds, and landing. So congratulations on our first script on making the drone autonomous. Of course, in a simulator environment. We're gonna do this in the real world also in very soon. So that's all for today's video, and we will perform some navigation in the next video. And I will see you in the next tutorial, and thank you very much for watching. See you soon.